Alright, using the square root procedure to solve the quadratic formula. And this is really just an introduction to completing the square. So, if you're faced with an equation, since the 8th grade, you just undo the equation. You invert your procedure, your PEMDAS, which you think of. So, your please excuse my dear Aunt Sally, or order of operations. There's the word I was looking for. So if you have 3x squared plus 12, to solve that, you'd subtract 12 from both sides. Again, there's two examples. We'll just do this first one here. And so you've got 3x squared. You could have also factored out a 3, but we won't worry about that right now and use zero product principle. But 3x squared equals negative 12. Then divide by 3. And so x squared equals negative 4. Okay. Then what you'd have next, and then here I got a third example below here, is to square root both sides. And so when you square root a negative 4, hopefully you've had a high school algebra course. You know that the square root of a negative is an imaginary number, which is I. So this would be x would have to be either the square root of 4 is 2 and the square root of that negative is an I, or x would be negative 2i. And so we always write that as x is equal to, geez, I've got too many equal signs. X is equal to plus or minus 2i. So there's your, your concise answer with as few symbols written as possible. But if you want to check to see if that works, you just plug in 2i. So you'd have 3 times, and this is kind of neat to use an imaginary number to get a real number. So it'd be 3 times 2i squared plus 12. Well, if you solve that, we want to end up with 0 here. If you solve that, you'd have 3 times 4i squared plus 12. Because, 2i squared is 4i squared. Well, if you know, again, anything about imaginary numbers, I squared is negative 1. So this would be 3 times 4 times negative 1, which would be negative 12. Plus 12 is 0. And so we know 2i is a solution to that equation. And it would be the same with negative 2i. Okay, so that's one way of approaching a quadratic when you have no middle term, if you want to think of it that way. Okay, on this problem here, we've got a lot of things set up for us really nice. We've got this x plus 1 squared term. And so what we can do is eliminate the squared term by square rooting both sides. And so, the square root of x plus 1 squared is x plus 1 equals, and then when you square root the 49, it could have been either a positive or a negative 7, because the square root of 49 is 7. So, why is that plus or minus, you might be asking? Well, I don't have a lot of time, but here in a second maybe I'll get to that. And so x plus 1 equals plus or minus 7. Then you subtract 1 from both sides. And so x is equal to negative 1 plus or minus 7. At the end of the video, I'll tell you why that plus or minus shows up there, or give another example of why it should be there. And so x equals, well, negative 1 plus 7 is 6. And x could be, for the other answer, negative 1 minus 7, which would be negative 8. And so here's your two solutions to that problem. And if you plug those in, 6 plus 1 squared is, 7 squared is 49, so that's true. And negative 8 plus 1 is negative 7 squared is also 49. So both of those work. Those are your only two solutions. Now for this third example, I just kind of threw in another imaginary number one. And it's very similar. So let me move this over a little. Since it's, x minus 3 squared, you can go ahead and just, sorry about that. You can just square root both sides of the equation. And so you'd have x minus 3 equals, well, the square root of a negative is I. And 45, I also threw this as an irrational number and an imaginary, but the square root of 45 is 9 and 5 and 3 and 3, and you have a pair of 3's, or think of it, the square root of 9 is 3. So this would be 3i for the imaginary, and whoops, and we forgot the plus or minus, and then 5. And so we've got x minus 3, just to rewrite it so it's not so nasty, plus or minus 3i square root of 5. Then the last step, we want x by itself, so we just add 3 over to the other side. And so x equals 3 plus or minus 3i square root of 5. And so that's the solution to that. Now that would be really ugly because that's a complex number that we're going to have to plug into that original quadratic to see if it works or not. And it will work, believe it or not. I don't want to spend the time showing you that in here, but it's ugly. So the next thing I promised you, this is the end of the video. So if you know why we add a plus or minus, then you're done. But if you don't know why we have a plus or minus, think of this example. Let's say you had x squared equals, let's just use 16 as an easy one. We want every single number that would make this true. And so when x squared is equal to 16, it could be 4. You automatically think, oh, well, 4 squared is 16. And so we know one of our answers is 4. But there's also another one, and that's negative 4, because every time you square a number, it becomes positive. So in this case, you have to have x is plus or equal to plus or minus 4. And the plus or minus, we write it that way just because math people in general try to minimize the number of symbols we use. We give you enough witchcraft. They try to simplify it as much as possible. So x is equal to plus or minus 4. There's two answers there. And you could do another example. X squared equals 25. Well, immediately you think, oh yeah, 5. Well, problem is, or not a problem, but negative 5 also works there because negative 5 squared is equal to 25. And I shouldn't do a run-on sentence like that, but you get the idea, I hope. And so your answer for this one is x is equal to plus or minus 5. And I hope that helps, and best of luck with these. Introduction to completing the square. There's going to be some more medium difficulty and very difficult completing the square problems in the future here. So best of luck, and I'll see you next time.